Okay, let's solve another system by determinants, but this time I want to show you how you can use the calculator if you'd like. Yes, I'm using R, S, and T. Pretend that's X, Y, and Z if you'd like. So to solve for the first letter, which is called the letter R, we would evaluate the determinant in the denominator that has a 3, a 1, and a 4 in the first column. A 1, a 2, and a 1, a negative 2, and a negative 1. Watch your signs in the middle column. A negative 1, a 1, and a 1. A negative 1, 1, and 1 in the last column. In your first column, when you're solving for the first letter, you'll put these constants, the 2, the 0, and the 3. I love zeros. They help me when I do these products. Here, bring up this column, 1, negative 2, negative 1. Here, negative 1, 1, and 0. Let's do the numerator by hand. So I'm going to copy the 2, the 0, and the 3 over. And then I'm going to copy this column, the 1, the negative 2, and the negative 1 over. So by hand, we took this product plus, ooh, this one has a 0 in it. Cool, I love that. So let's see, this product is a negative 4. And then this product, 1 times 1 times 3 is 3. And this one has a 0, but I'm just going to show it. And then I'm going to subtract this product, ooh, another 0, good. So 3 times a negative 2 times a negative 1 is 6, and it is just a positive 6. Negative 1 times 1 is a negative 1, times 2 is a negative 2, and then the last one is a 0. So this numerator right here turns out to be a negative 1, and then we're going to subtract 6 and a negative 2, which is 4. So the numerator for this R value that we're solving for is going to be a negative 5. All right, let's let the calculator do the work for us. If you would like to do this, I think I'm going to bring the calculator down here a little bit. Oh, I'm trying to minimize. What am I doing here? There we go. Yeah, I think this will work right here. All right, so I'm going to clear my screen. And then, do you see this word matrix above the x to the minus 1 key? And it's in blue. So I'm going to hit my second key and the matrix key. And there are 3 menu items here under that matrix menu. What I'm going to do is edit what's called a determinant. I'm going to go over here and edit it. When I'm in this menu, I'm going to have it evaluate a determinant. And as you saw in the first menu, I'm going to call them A, B, C, D, E, F, whatever. So I start over here at edit. And I'm going to have to move this up a little bit. So I'm going to hit enter. And I want to put in a 3, so I'm typing in a 3, and I'm hitting enter right now. And 3, and I'm hitting enter right now. And it says, oh, you must want a bunch of zeros in it. Now, I want to do this numerator, so my problem is my enter button is concealed on my calculator. I got to move it up. So I'm going to attempt to type, actually let's go for the denominator. No, we got to go for the numerator because this is the one we just calculated by hand as a negative 5. So I'm going to put all these numbers in right now into this matrix. So I'm at least going to let myself see the 2, and then I think I need a 1 and a negative 1, and it goes left to right. The next number is a 0. And then I think I'll need a negative 2 and a 1. And then this first column bottom is 3. And then I think I need a negative 1 and a 1. And hit enter right there. Make sure you hit enter after that last one. Now I'm going to look and see if 2, 0, 3, 1, negative 2, negative 1. Yeah, I think I got this incorrectly. All right, so I've edited the matrix. Whatever you do, go second quit right now. And then go second matrix again. But now instead of going over to the edit menu to put the numbers in, we're going to have it evaluate a determinant. So it's sitting on number 1. So we say, okay, go ahead and find the determinant. and then second matrix for a third time. And because we have a 3 by 3 in number 1, I'm going to hit enter right now because it's in number 1, and it's going to evaluate the determinant for what's called the matrix A, and I hope it's going to be the 5 that we got. We got a -5 for that. So it did it for us. So let's go ahead and do this one more time. So I'm going to hit clear, and let's go second matrix. This is the whole process all over again. So you go over here to edit. I guess I'll put it in B. So I'm going to hit enter, and I'm going to put in a 3, enter, 3, enter, and I'm going to do the denominator, which is these numbers in front of the A's, B's, and C's. So I'm going to work right this way. So I've got a 3, a 1, and a -1. And then this 1, -2, and 1. So 1, -2, and 1. And then this 4, -1, and 1. So 4, -1, and 1, and hit enter right now. Please quit. Please right here quit. All you've done is edit the matrix. Now go back to second matrix, and under the math feature, grab the word determinant because you want to evaluate the determinant. Again, under the matrix, second matrix, you want to go to number 2 to evaluate B. And I like to close my parentheses, and the value for that determinant was a -7. So right over here, I'm going to put a -7, and I have now found out that R is equal to 5/7. If you do that same process and you evaluate the determinant for S, you're going to get a -6 in its numerator, and it already had a -7 in the denominator. So S will be equal to 6/7. And finally, when you do this for T and evaluate the numerator, you're going to get a -7. The denominator is a -7, and a negative divided by a negative is a +1. So the solution to this system is 5/7, 6/7, and 1. R, S, A, B, C, Q, R, S, T. And those are in alphabetical order. 5, 6, 6, 7, and 1. Okay, we may evaluate the story problem down here via determinants. We'll see. So let's go ahead and do one. A mail order company charges $4 for shipping orders of less than $50. $6 if your order is between $50 and $200, and $8 when your order is over $200. Before we read any more, let's go to the last sentence. It is in the last sentence. Find the number of orders shipped at each rate. The number of orders shipped at each rate. And that last sentence is going to give us a little bit more information, but let's let X represent the number of orders that are less than $50. And let's let Y represent the number of orders that are between 200 and between $50 and $200. And let's let Z be the number of orders, $8 for orders that are greater than $200. Okay, and now let's go ahead and write our sentences. So $4 for X kind of orders, each of them, $6 for the Y kind of orders, and $8 for the Z kind of orders, and one day their total shipping charges was that much. So let's write the value statement from that. So $4 for the X kind of shipments, $6 for the Y kind of shipments, and there's Y of those shipments, and $8 for the Z kind of shipments, and the total value of all those shipments is $2,160. In that, there are 384 orders. You know, I kind of like my total statement to be first. So X plus Y plus Z, the total number of orders is 384. Finally, find the number of orders find the number of orders shipped at each rate. If the number of orders under $50, that's X. If X X is 12 more than twice the ones over 200, which is Z. 12 more than twice the ones that are over $200. So when I get the 2z over to the left side, I'll have an x, and then I'll have a minus 12z here, and then, I'm sorry, it's a 2z. I'm going to move this equation down. So it's x equals 12 plus 2z, and I'm going to subtract 2z from both sides. So I'll have x minus 2z equals the 12, that number 12 right here. And now this is in standard form. So let's go ahead and I'm just going to set the determinants up. So the denominator would have a 1, a 4, and a 1 right here. The middle column would be a 1, a 6, and a 0 right here because there is not a y term. I'm writing it in green because it's just not there. I'm writing it kind of lightly. And then a 1, a 8, and a negative 2. Upstairs, I'm going to have these big old numbers, the 384, the 2160, and the 12 in the first column, but then I'll bring up this 1, 6, and 0 right here, and this 1 and 8 and a negative 2, and I will evaluate these determinants, and I have found, I'm looking to see that I've got these, that this numerator turns out to be 264 divided by 2, which is 132. I have to tell you that yeah, that should be fine. I did write my equations in a different order, but I think that should be fine. So 132 for x. You would very easily then be able to solve for z in this equation without using determinants. And z turns out to be 60 orders. And then finally, x plus y plus z has to be 384. So y turns out to be in this problem, I'm looking for my answer. Where is it? Y is 192 orders. So again, does the 132 plus the 192 plus the 60 add up to be the 384? Then can you take $4 times the 132 plus $6 times the 192 plus $8 times the 60 and get $2,160? And then check it in the third equation as well. This ends our study of systems of equations, and we finished with the more difficult topic of 3 equations and 3 unknowns.